The following is the video solution from JSDT Solutions. Question 9, and they already make a statement. Provide reasons for your statements in questions 9, 10, and 11. Question 9 says, in the diagram, ABCD is a cyclic quad. BC is produced to E, AC is drawn, and then they start telling us these, which is going to be important. Angle A1 is equal to a half of angle B. Okay, so whatever angle A1 is, it's half the size of angle B. Okay, so this will be the bigger angle, and that's the smaller one. So if, for example, if this is 20 degrees, then that is 10 degrees. Okay, A1 must be half of B. And then angle A2 is 46 degrees, and angle C1 is 86 degrees. And the first question is to calculate with reasons the value of angle A1. Okay, so how do we find angle A1? Do you see that we have an exterior angle? We have an exterior angle in a cyclic quad. The exterior angle is always equal to the opposite interior angle. So it means angle A1 plus angle A2 would give you this exterior angle of 86 degrees. And that's what we're going to do. So angle A1 is what we're looking for. Angle A2 we have as 46 degrees, and that should give us 86 degrees. And then we'll put our reason, exterior angle of a cyclic quad. Okay, and therefore angle A1 is going to be equal to, if you take 46 degrees over, so 86 minus 46 is 40 degrees. And that is our answer. Question 9.2 says, hence, prove that AD is equal to DC. So we have to prove that two lines are equal. So we need to prove this is equal to this. Okay, so that would mean that this should be an isosceles triangle. And something else we know about isosceles triangles, apart from two sides being equal, is that two angles will be equal. Specifically, the angles opposite these equal sides. So this should be equal to this angle. Okay, I'm not saying they're equal yet. We just need to show them that those two angles are equal. And if we can show them that, then it automatically means that these two sides are equal. Okay, we are working with numbers here, and we do know the size of angle A1. It's 40 degrees. We found that in the previous question. What we need to find is angle C2. If we can find that angle, it should be fine. Now, looking at it like this, you can see that we have an exterior angle. But this is not very helpful, because if this is your exterior angle of this triangle over here, you would need this angle for you to even find out what that is. And we don't really know what this angle is. But they also leave some information here. So let's look at what they say in the top. They say angle A is equal to a half of angle B. Specifically, they said angle A1 is equal to half of angle B. So we have that. Angle A1 is 40 degrees. If angle A1 is 40 degrees, then it means that angle B must be 80 degrees. Okay, so let's put that down. Angle B is therefore equal to 80 degrees. Okay, so we can just tell them, given that A1 is equal to half angle B, so we know that that is 80 degrees. And now this actually helps us. We can now use the exterior angle of a triangle to find angle C2. So we're saying that this angle, because we have this triangle over here, the exterior angle of a triangle will always be equal to the sum of the two opposite interior angles. So add this angle with this angle, and you should get this entire angle, which is 86 degrees plus angle C2. Okay, so 86 degrees plus angle C2 equals 80 degrees plus 46 degrees. That's what we have over here. Okay, and the reason for that is the exterior angle of a triangle. Okay, so let's go ahead and solve for angle C2. Angle C2 is just equal to these two added and minus 86 degrees. Okay, so which is equal to 40 degrees, because you can just cancel 80 degrees from both sides and you have 6 degrees. You take it over. 46 minus 6 is 40 degrees. Okay, so there we go. We found that this is equal to 40 degrees. So if angle C2 is also equal to 40 degrees, do you see that we have equal angles? So it would mean that the sides opposite those equal angles must be equal. Okay, angle C2 equals angle A1. Therefore, that means that that line AD must be equal to DC or CD. So let's say AD equals DC. And the reason for that would be, so you see how when you have a triangle and they tell you that two sides are already equal, then you can show them that these two angles are equal. And the reason for this would be angles opposite equal sides are equal. That those angles lie opposite equal sides, therefore they are equal. But you can see in this case, we found that the angles were equal, and we are proving that because of that, the sides are equal. So this would really be the inverse of that. So it's the sides opposite equal angles that are equal. That will be our reason. Okay, so there we go. We have proven that AD is equal to DC. And that is it for question 9.